Like, how close do you get? Don't make sure you don't see my belly.
Right. That's good. Good morning, Gregor.
Good morning. How are you today?
Good. So, Gregor.
Wait a minute. What are you asking me? So, well, actually, it was not founded by me. It was founded by Robert Ginsberg. So he had worked for Shell on the modern carbonates in the Bahamas. And when the Shell research group, or the Shell decided to close their research on modern carbonates, he became a professor first in Chicago, and then he came down to Miami, to the University of Miami, and he started to run this consortium as Comparative Sedimentology Laboratory. And at the time, it was mostly designed to look at the modern process and look of how the sedimentary product would be in carbonates.
And how do you collect the funding? How do you invite the people to?
So the way we invite is we put together research projects per year. Some of them, of course, done more than 1 year because it's mostly done by students. And then we send these research prospectus out to students and to the companies, and then the companies join or not. So we invite them to join the consortium. And when I took over as the director of the CSL, the Comparative Sedimentology Laboratory, we also realized that, well, it's not just comparative sedimentology anymore, because we do geophysics, we do petrophysics, we do a lot of chemistry. So now we call it the CSL Center for Carbonate Research, because I think, especially with carbonates, you cannot just look at one aspect. If you want to understand carbonates, you have to have a bit of a holistic approach. From the physical processes, the biological processes, the chemistry, all that is very, very important.
But how much is about basic science? And how much are you devoted to give answers to the sponsors, which they are mainly energy companies?
Interestingly enough, our consortium sort of is viewed as the group that provides the fundamental research to try to answer fundamental questions that eventually can be used in exploration of hydrocarbons or production of hydrocarbons. But we don't really directly apply to an oil field or anything like this. We really do fundamental research. These are all PhD or master's projects which have to answer a scientific question.
So you don't feel that you are driven or steered by the sponsors?
Well, only in the way that as the demand for knowledge changes within the industry, we would maybe change the focus from here to there. So, like for example, in diagenesis for many years, well, it was what causes all the porosity, if you look at how can you say which fluids alter your rock? Was it originally, was it later, was it during hydrocarbons coming in? And you do that now with geochemical traces, and most recently with the clumped isotope, a technique that Peter developed and refined for carbonates, and is highly successful in doing diagenetic work. And that basically, he says, makes all the former studies in stable isotopes obsolete. So in that respect, we do fundamental research, but also it was sort of steered a bit by the demand of the companies.
Yeah, but that's important, because then it means that you are not driven by pure curiosity. You are driven by the main hot topic that the sponsors are asking you. Is that right?
Well, yes and no. There is sort of a mixture there. And we of course have projects from our students that are not of very limited interest to the oil companies, and sometimes we also don't present those, or they're not funded within that. So, but within the consortium, for example, the curiosity, deep water carbonates right now. So we started to look at the slopes and the deeper basins of the carbonate systems for many years, and even before deep waters were even in demand, and got recently very good opportunities to go out with ships to do multi-beam ROV work with submersible, and got a lot of really good data in the Straits of Florida and around Great Bahama Bank.
So in other words, it seems you can do what you really would like to do.
Correct. Yes. So it's also, I think, the rule number one is that you design the project, and admittedly, you need some input sometimes from other people. And also within the center, the CSL is an official center in the University of Miami, you need to have an advisory board. So, and our advisory board is from scientists from oil companies. And they, the last day of the meeting, is always where the projects are discussed and we get input from the scientists on these projects. And I have to say that these geoscientists from the oil companies, of course, they also estimate fundamental research because they know that some fundamental questions are not answered yet and somebody needs to look at them. And so they very much work with us to try to answer the fundamental questions.
Would you have the same results and excitement, or would you have the same funding without the sponsors? I mean, can you replicate the things that you do in a war without sponsors?
Probably not. No.
And would it be better or worse?
So in the last 20 years, it's the funding within the National Funding Agency for National Science Foundation, the Department of Energy, has declined. And the direction of in this funding agency has gone much more to climate change, paleoceanography, and the work that we do. In many cases we have problems getting funding within the National Science Foundation. We got quite a bit of funding from the Department of Energy and the Fundamental Research Subdivision and from the Ocean Drilling Program to do work on our slopes of the Great Bahama Bank and things like that. But for the National Science Foundation has very limited money. So our contributions to our research has shifted from like 60% NSF money and 40% from industry to nowadays maybe the other way around. So the proportion has changed.
So it's a must. There's no choice.
Well, but it's a must only because we choose that route. I mean, I'm sure it's one way to get the third source funding, and if you have a consortium like this, if you're not tied to individual projects, I think you have more freedom academically to branch out and to look at different aspects of carbonates.
How much of your time is dedicated to the management of the consortium, so things unrelated with science?
Well, I would say that half of my time now is with the management. You know, if you have 14, 15 oil companies, you're dealing with 14, 15 funding agencies. So you have to make sure that all your funding agencies get the deliverables that you told them.
So you still have time to do the real science?
Well, what I need to do is, of course, all the students, when they go to the field, either here in the Neocan Basin or in the Bahamas, you know, I go to the field with them. I go to these cruises with the big ships that do seismic multi-beam work in the Straits of Florida. I'm on the ship for 4 weeks. Last 3 years each time I was 4 weeks on the ship to collect the data. I go to these colleagues in Germany and work with them on the data. So I try to do as much as I can.
What is the most difficult thing to deal with in your position as a professor and director of a consortium?
Well, if you do management and research, the most difficult thing is that not too many things fall between the cracks, and sometimes they do, and sometimes it's more important things, and sometimes smaller things fall through the cracks. But it's like the day has 24 hours, you know, and sometimes it's just something that gets lost. So it's really the time management is
so you need a lot of prioritization. You have to give your priorities.
Correct, yes.
And which are your priorities?
Well, my priority is to do good research first of all.
And publish.
And publish, yeah. So the second aspect of the consortium is, and that's really to my heart, is that the knowledge distribution, the knowledge transfer. I always thought if you're on the academia, you produce a lot, but unless it goes out there to the people who work with your data, it's sort of not very useful yet. Yeah? And so the knowledge transfer, I think, is a real problem in not just geology in general. And so part of our center, one of our missions is to make knowledge transfer. All the data that we have, we distribute it to our industrial associates, we put it on the website for other people, we publish a lot, and we try to give short courses, field seminars, to disseminate the knowledge that we acquire in all these projects. because this is a really important aspect. And it's one of our missions.
So it's not sufficient to publish a paper?
That's one way of transferring knowledge, but I know from my experience that many people don't like or don't read that many papers, you know. If you're out there, let's say you're somewhere in a federal agency with groundwater work and all that, you don't read too many papers. Your daily tasks are way too big or time-consuming that you have time to
So
read.
how would you recommend a professional, a researcher, or a student that they want to distribute and transfer their knowledge, something more than writing a paper?
Well, I think something like you do now here, you know, the modern technology has helped that distributed much easier over websites and presentations that are put back on the websites that actually other people can go and listen and see what you have done.
But those things are not peer reviewed, so the quality could be less.
Well, that's true, but I mean, in the classroom teaching is not peer reviewed either. You know, either you will always make mistakes when you teach, you know, but a good teacher is very important for a student to develop, you know, and the students and the people who listen to it, they will catch immediately if it is good or not. You know. They will be your quality control. They will be your peers themselves. So they are. Wait a minute, they say, listen, I don't believe that. You know, you have to, if you need to be able to convince them, just as you would be able to convince a reviewer of a paper or something like that.
Talking about students, when you talk with your many students, what do you tell them about the relationship between being a specialist and a generalist? Do you encourage them to focus on their topic or to be broader?
Well, a student in his research topic, he needs to be at the top of the field, because he needs to, as a PhD, to complete the PhD, you need to have advanced the science in that field. But you can build a pyramid higher and higher if you have a wider and wider base. If you have a very small base and you don't have the knowledge of all the disciplines around it, you will never go that high. And I think, especially in carbonates, that is really an interaction between chemical, physical, biological processes. You need to understand these processes to advance your field, and so you need to have a holistic approach to research. And yes, in your field, you try to get to the top, but you need the basic knowledge on many areas that you, if need be, can incorporate it into your research.
What are the key questions that you have in the field of carbonates sedimentology?
Well, right now, I think one of the hottest topics is that we try to understand the sea level oscillations within the larger sea level cycles. For many years now, we have always focused on third-order sequences and the Milankovitch or the orbital forced climate changes and the sea level changes related to that. And now we start to realize that we have these rapid oscillations of sea level within low standard glacial times and the high standard interglacial times. And unfortunately, that knowledge has not made the life easier. It complicates many things that we thought we had a protective tool, like using astrochronology in carbonates. It seems we cannot do that, or it's very with a large uncertainty. So this is really one thing that is a fundamental thing that we need to look into it. How much uncertainty we have by that, we still don't know. That's ongoing research. And the other one is for the deeper water. The new geophysical tools with the multi-beams, the good seismic, have now opened up the landscape or the seascape in the deeper ocean that we haven't seen before. And before we did shoot single channel seismic line down the slope perpendicular to the margin, so we always had a depth-dependent processes that we looked on, the facies distribution. Now that we have the whole seafloor imaged, all of a sudden we realize there is a whole different world down there, and we see mass transport complexes in carbonates, we see coral reefs everywhere, deep water coral reefs, we see drift deposits and the influence of bottom currents. all these processes that go on in the deep that have not been visible for many, many years, up till now that we have to do geophysical tools. And it's really fantastic world down there, I have to say, really beautiful.
Thank you very much, Gregor. Thank you.